This episode of Tukatalks discusses how the use of technology eliminates processes in apparel manufacturing. We take great care to maintain neutrality on Tukatalks as it is an educational platform, not for sales or promotional material. The specific examples of technology mentioned in this episode are software and machinery developed and sold by Tukatech, the fashion technology company owned by Ram Sareen. However, we believe the information shared in this episode will be of value to apparel businesses regardless of their technology systems.
We are not a shirt maker or a t-shirt maker. We're not a bra or a panty company. We're not an outerwear or suit company. Those are the specialty products. But 90% of the products require most of the machinery which is common for all of them. In the utilization of machinery, our number one focus is to make sure that the machine is going up and down, always. If it stops, it better stop for a reason. I can't go faster. I not look at what is my dead time. How do I recover from there? That's not my machine working faster. That's not my people working faster. That's my efficiency that I created by re-engineering my process. Well, hello there from Los Angeles. You've heard the cliches like necessity is the mother of invention, proactive, reactive. There has never been a time like today when you need to re-examine your entire business. Let's define where are the opportunities, forget about the challenges. We need to think how a startup is setting up a business today, a manufacturing business, especially in the cut and sew. And I did not say apparel, I didn't say furniture, I didn't say aerospace, I didn't say any of the automotive interiors or anything. At the end of the day, all the cut and sew is got only two things: cut and sew. We box ourselves by putting this is what we cut and sew, therefore we are a factory making this. We're not. So that's the first thing we need to look at. How do we eliminate that thinking process, or how do we get out of that box? And all of a sudden, you'll find a huge opportunity all over. Now let's look at some fundamental rules. The rules are, if we are going to set up an engineered operation, we need to look at how do I best utilize A, fabric, B, labor. When we talk about versatility, remember we said we do two things. We do cutting and we do sewing. When we are spreading, the machine doesn't know what product is being spread. We are spreading yards. So we need to literally focus, how many yards is this marker length? How many layers do we need to do? And what kind of fabric challenges do we have? Just stay within those parameters and continue with your spreading. When it reaches the cutting, cutter doesn't know what product is being done. They only cut geometrical shapes, whatever the perimeter inches are, whatever the attributes are. I need a drill hole here. I need a notch here. This is the kind of notch. Question now is, what is that product? Cutter doesn't know. So it allows me to really engineer by taking, if this is the common fabric, and these are the 20 styles that I'm doing, but the quantity is not big enough, maybe I can combine all these 20 styles, make a longer spread, make a higher spread. Spreader doesn't know what fabrics and what styles I'm spreading. It just gives me a better efficiency of a longer spread without having to stop. The cutter doesn't know what styles I'm cutting. So whether I have these 20 styles or 10 styles, shirts and pants, jackets and pants, whatever it is, so long as it's the same fabric, and cut it together. Bundling is where we separate it out. Go to the sewing room. All this nonsense, and I mean this. I have this many lines. Stop with this nonsense. This was the American way that killed the industry in America because we were trying to make long lines or some lines where we make the same product. The operator, first operation, second operation, third, up to 15th operation, they don't even know what product they are sewing. What do they do? How do you really plan your sewing room? You plan your sewing room. This is the operation I need to do, or what machine do I require? This is the operation, the second one, that what machine do I require? How long does it take? How many number of machines do I require? Right or wrong? What if I had another factor there? Which person can operate this machine? Go one step even further. Which person can operate this machine, shorter seams or longer seams? The operators are not sewing products. They're joining two panels. Whatever the length of the panel, or putting a panel on top of this, whether it's pocket set or collar set, whatever it is, we are defining. Till about 90% of the product is assembled, they don't even know what products they were sewing. We are boxing ourselves into this. And we're creating this line, and this line is not balanced with the other one, and I have this machine not being utilized because I have duplicate machines required. I don't have the machine utilization, people utilization, because I started this mess myself. So we think a little differently. We think which machines are required, which people are required, and we put the work accordingly, so long as there are no thread changes required. So this is where the stop comes in. If the thread changes are required, maybe I will put one color to one machine, another color to another machine. That's where the separation will come in. Spreading fabric. Spreading fabric is the most skilled job. But there are things which are done before and skills which are required to do things during and after. In apparel or in fabrics, if we look at from a 35,000 foot view, what do we do in the cutting room? We lay the material. It doesn't have a name there that this is a marker for making pants or shirts or jackets or children's garment or outerwear. Is this a lining or interlining or shell? Is it a whatever it is fabric that we are laying down. So if you're laying down the fabric, there are some factors in there. What kind of fabric it is and what are the challenges in laying the fabric. Only focus on laying the fabric. Second thing is, whenever I'm going to put anything, whether it's machine or person, the only thing I'm going to consider how I'm going to engineer is what kind of utilization of the people or the machinery do I have. So let's take an example in the sewing room. We all know that the only time the production comes out is when the needle is going in and out. So we got to separate ourselves from how we do things. We need to look at how do we get more needle time? How do we engineer the process so that the product is under the needle and needle is running up and down? Anything which is fumbling and so on is not going to work. By the way, just for your reference, for those who do not know this, the average needle time in the best engineered apparel factory, I said apparel, is about 8%. That means only the 8% of the time in the entire day, the needle is going in and out. For those who don't believe it, email me and I will tell you how to calculate that. But this session is not about sewing rooms. In spreading, the only time we are getting production from a person or a machine when the machine is going up and down, laying the fabric. In the cutting, the only time we get in the productivity is when the knife is going up and down, not going from one piece to the other. We call dry hole time. But how do we get the best utilization of these machineries first? And then we look at how do we get the best people utilization. To start, I need to what we call setup for the table. Where do I start to spread? Where do I end the marker? So lay it either on a piece of paper, my start point, my end point. How much extra do I need on each end? I mark that. Put the marker on down there to mark on the brown paper or underlay paper. And then I put splicing marks. What am I doing? I am doing what we call setup of how I'm going to spread this marker. What's happening to the machine? So the machine is sitting idle. I created a mechanism on my spreading equipment where I have the setup done automatically by unskilled person because I'm sending the marker data as planning for that spreading utilization for the day. I'm scheduling the spreader. I want this marker. System knows from the Tuka plan how long will it take based on the past performance. There's artificial intelligence in there. As the performance changes, so does the plan. So if I'm doing 12 yards a minute on the average, and this one has 4,800 yards, the system very quickly calculates what will be my net spreading time. I also have allowances of the startup time and the finishing time or in between the two. And now I've just blocked that many minutes of that spreader. I've sent that marker digitally or through Wi-Fi to that computer, which is on board on the spreader. When I, as an operator, start, I don't have to be a genius. I can be literally off the street and start running that spreading machine in 30 minutes. 30 minutes. I need to have other skills. I need a person who can look, identify the flaws. Maybe a person who's working as a QC person. Maybe a person as a final inspector of the garments. Preferably a woman who's got a very good eye to look for defects. What am I doing? I am looking for a person who can do 100% inspection of my fabric. Now I start spreading. But what was I doing before? We pre-inspect the fabric. Our objective is to know many things which can be highlighted during pre-inspection. But we're not doing 100%. We're doing 10%. Well, statistically speaking, even if the 10% found some flaws, what is the end result? Doesn't matter what we do, how we do it, but this is what we end up doing. We end up spreading and cutting that fabric. Unless that fabric had such drastic problems that we have to send the entire thing back. Mostly never happens. So my objective was to identify and then make a claim if there is and notify the supplier. And I may not have time to do all this because if I'm going to waste 5, 7, 10, 20 days till the resolution is done and what the end result is going to be, I'm going to still spread it, I'm going to still cut it, but I know that I'm going to get this much credit from the supplier for my bad quality or their bad quality. What if I was to do 100% inspection and during the inspection, I see the flaws and I make the decision what to do with the flaws. If I have to splice it to cut it out, if I have to overlap it because it's a small piece, or if I have to leave it because it's falling into the waste area, I can always have all that statistically reported by the machine how many yards were on that roll, how many yards were really on the roll as it went through the machine. The encoder tells me your planned number that you said versus the actual fabric that went through. And then it gives me subclassification. Out of that 100 yards, I did 98 yards of actual spreading off this many number of layers. And this was the one which was used in end losses. And this was the one which was used in the splicing for flaws. If I could go with my claim based on the actual wastage, everybody's happy, but I don't have to stop the production. Recapping this for a minute. I did not want to pre-inspect. I inspect on the machine. I did not want to waste the time in setting up, and I've done that through my software and my online. Now comes the question, flaws. If we see something, how do we know where does it fall? The system has a projection of that marker image. So I, as an operator, see the entire spread. If I see a flaw, I see it on a picture where the flaw is if the marker was there. Average 80% marker, 20% chances are that could be falling into a waste area. This is a better way of managing flaws in a real time with a real location and position of that flaw, rather than hypothetically thinking, I have this, I'm going to have to do cut panels, I'm going to have to do panel inspections, and then take it out and recut. Not necessary. Hey, there's 3% chance that it is going to be in the seam area. It's a small enough flaw. Leave it. Leave it if it's in the waste area. But if the piece is too small and I don't want to have a big splice, I can take a small end of the other roll, put that on top, and mark it so I know one piece is good, the other one is not. If the flaw is big or the piece is big, we splice it. Prior to starting the spreading, we need to look at what are we going to spread. So instead of really locking yourself, I have to cut 8,000 units in this scale, in this color. I have these 20,000 yards. I'm not going to be able to cut, in one spread. I can do 100 layers. I'm doing 10-yard long marker. Maximum I'm going to be able to lay is 1,000 yards. Can I identify what is the die lot? What is the weave lot? Can I identify how the mill was working, where they have already done this, either from yarn or from the weaving or from the knitting or from the bath or from the dye? Whatever it is, I'm not going to ask them to change their processes, but I want to work with their data so that I can identify when I receive the fabric which ones are how many dye lots. So when issuing the fabric, I'm going to start utilizing through Tukatech plan, not the entire cut. Working backwards, I have 2,345 yards in this dye lot. I have 2,810 yards in the next dye lot. Okay, let's start with that. So first thing we are doing is, by taking that, we're making sure they are all within the same shade. And we have not compromised that shade by opening the plastic. We do not want to open the plastic wrapping. And that thing is sealed with the humidity and the temperature and the atmosphere of that mill. And the moment you puncture that, that thing goes in. You may not hear that, but that's exactly what happens. And all of a sudden, you're opening your fabric to an outside assault caused by you, by your process. Leave the fabric alone in the darkest possible place so you don't have any exposure to light, moisture, atmosphere of your factory. We bring it to the spreading table and we open it up as we are ready to spread. Now, my planning parameters are, I have still that many units to cut, but the availability is 2,310 yards from that dye lot. And I now go back and check, not from my original plan, what the width that I planned, what is the actual width of this material in this dye lot. And that, my friends, will vary from one dye lot to the other, guaranteed. So if I have separated my dye lot at the receiving, whatever lot you like to call it, but go back to mill and say they were making a 1,000-yard roll and you wanted 50 yards, they gave you $20. 100 yards, they gave you 10 rolls. Simple math. First thing you do is ask them to give you as long a roll as possible. And I mean that. And we can make machines to handle up to 1,000 kilos. So it doesn't make a difference. But your objective is minimum number of roll changes, minimum number of width variation, minimum number of shade variation, working from the same, reproducing. But if I can't get the 1,000 yards, maybe I can get 5 rolls of 200 or 10 rolls of 100. Because every time I have to change the roll, guess what? I have to stop the machine. So we'll talk about that, how to engineer that. But again, if you don't have that many rolls, less number of steps. I now plan what markers do I need to utilize 2,310 yards within the parameters, the length and the height that I can use. And the system gives me a cut plan for that fabric lot, for that width, for that shade. So I start spreading. I finish here. I'm just taking the next roll. So I'm rebuilding that 1,000 yards on the table. Believe it or not, for those who are just sitting here and thinking, what a crap it is, this crap works. And when I started there, we had no calculators, we had no CAD systems. We didn't have all the technologies, all the information that you already have today. I still have all the frustrations in my head. I didn't write this software because I thought of something. No. These were tested challenges, and based on those challenges, we wrote the solutions. I grew up in Canada. Versatility started in Canada, not America. Americans were so used to making one product, one factory, one plant, and make the same shit again and again and again and again. The moment that things changed, they didn't know how to really pivot. And guess what? They moved those factories to Asia. You do the same shit again and again, and you guys said, okay, give me those big quantities. There's no engineering required. I don't need people. I can engineer all these processes. Look at automotive, look at the automation available. Versatility is Canada. When you have only 22 million people when I started there, and you have this country, huge big country with 5 or 6 major metropolitan cities in the entire country with the different climates, how do you scale your business? What do you make? We had factories where we were sewing wool in the morning, silk in the afternoon, cotton in the evening. This is where you need to be today, versatility, to be able to cut and sew whatever you need to do it. Going back to spreading again. Please note, we do not print markers. We are going to need the marker for cutting, but we will not print it. A digital Excel report must go to the cutting room manager, cutting room engineer in charge of cutting room, who will verify that this is the width the marker is made, this is the length the marker is made, this is the marker that has been sent to the spreader, and verify to make sure the fabric that we thought, that you told me, that I planned for, is what you say it is, the width. I think everything is okay as a cutting room manager. I press the button and the marker gets plotted. I'm not going to need the marker for spreading, but I'm going to need that for cutting. So by the time they spread it, I will have the marker printed. If I find that the marker that is made is different width than the fabric, I haven't spread anything. I just send that back to the smart mark, new width. It makes a new marker, sends the marker to the spreader. Spreader now sets up as ready to go. Assuming everything is working with the plan, I said this width, it is this width, fabric is this width, marker is the same width. Second set of verification or validation. The spreading person, when they spread the first layer, remember, this spreader has projection of the actual marker showing. So I don't have to bring the marker to open up to see if the width of the marker is same as the width of the fabric. I have the actual picture. I see it, and if I see width variation of my fabric that I laid versus the digital data of the marker width, I stop. So now becomes responsibility not of the cutting room manager, but the other person who must verify after the first layer is the person who's spreading. And these are the SOPs that we must put in, because once the fabric is spread one after the other layer, I have no recourse but to cut it and waste. So who am I going to hold responsible? I'm going to hold two people responsible. First, the cutting room manager, and the second, the person who's spreading it. So again, going back to utilization of materials, utilization of machinery now. In the utilization of machinery, our number one focus is to make sure that the machine is going up and down, always. If it stops, it better stop for a reason. I see a flaw, I don't know what to do with it, but I got to make a decision. I got to stop because that roll is just finished. I need to now change the roll. Roll changing time versus the number of minutes. In 8 hours, we work 480 minutes. Fabric average is about 50, 60 yards in knits and about 90 to 100 yards in woven. That's where the averages are coming in. So if I'm going to spend 3 minutes on changing the roll, threading the machine, getting it ready to start spreading, I'm already a very efficient spreading operator. This is the industry average, 3 minutes per roll changing time. So if you're doing 10 yards a minute, 4,800 yards in one day, and it was 100-yard rolls is 48 rolls. 48 times 3 is almost 150 minutes. The roll changing time. I can't go faster. I now have to look at what is my dead time. How do I recover from there? What if I reduce that to 1 minute? I have 100 extra minutes. That's 1,000 more yards. That's not my machine working faster. That's not my people working faster. That's my efficiency that I created by re-engineering my process. Now, if I have more than 1 or 2 or 3 machines, and if I start saving 100, 100, and 100 minutes, all of a sudden I have half a machine or another machine extra, depending on the size of my cutting room. So how do I do that? In a worst possible scenario where it could take 5 to 11 minutes is when the operator stops, takes the machine to the end, goes to the fabric, whether it is on a pallet or a rack, brings that fabric on the table, cuts the plastic off, record that item, what it is, on to their sheet for number of yards on that roll, takes the tape off, put it in the right direction, and then load the machine. While all these steps are being done, the machine is not running. What if I had a service person behind whose job is exactly the same thing while this machine is running, that person opening the fabric roll, taking the plastic out, taking the tapes out, recording how many yards it is on this roll, take the ticket out, put it on the loader in the right direction and bring the loader up to the loading place. Even that time the loader goes up is already engineered. So the operator stops, put the cradle down, push this, and I'm 34 seconds later on the spread. That's how you increase the productivity on the spreading machine. And this person is hustling between 2 or 3 tables because it is his job to make sure that roll is always ready. Third thing, we are not going to relax the fabrics. Doesn't matter what it is. Throw me a challenge, whatever you have, and I'm telling you, there is nothing that you can come up with, whether it is a 20%, 50%, 30%, 10%, 5% lycra stretch or whatever, whether it is a 4-way stretch, whether it is a stretch in the weft only, whether it is cheating done by the mill who pulled it too much and 100 yards showing is really 98 yards. It doesn't matter. This is the value of experience that we bring in. We've been there, done that, fixed it, and moved on. But we are not going to go back to because somebody said you've got to do this. No. I can prove it, show you, take you, and do it. So you're going to have to trust this. Don't listen to anyone who says, but in our business, we must do that. Or our customer says that. Doesn't make a difference. If you're going to invest the money in engineering the process and put the equipment and then still do the same shit the way you're doing it, then don't invest the money. Continue and go out of business. Don't make a change and do the ROI on that. With all the investment that you've done in the building and the people and the factories and everything, don't make a change. And then do the ROI. If you don't make a change, when do you go out of business? Because guaranteed you will go out of business. Change is constant. Growth is optional. Seriously, guys, let's get ourselves out of this rut. We are not a shirt maker or a t-shirt maker. We're not a bra or a panty company. We're not an outerwear or suit company. Those are the specialty products. But 90% of the products require most of the machinery, which is common for all of them. This is the way we engineer the cutting rooms, because that is where everything starts. You fix that, you fix everything in your operation. This is what we call setting up the factory for people who just know how to press buttons. And that's the way it should be. I have the team, I have the talent, I have the people, I have the equipment, I have the knowledge, and I tell you something, sooner you get there without resisting, all of us will succeed. And my name is Ram Sareen, and that's the way I see it.
Thanks for listening to this discussion presented by Tukatalks. If you found something in this conversation insightful, we would love for you to click the share button and send this episode to a friend.